Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss another topic from the chapter hydrocarbons. In the yesterday's class, if you remember, we have discussed one chapter from hydrocarbon, the second chapter I would say from second topic from the hydrocarbon chapter I would say, and today we are going to discuss the third topic from the same chapter, hydrocarbons. Okay. Yes, so let me just write down the title for this topic and we are going to discuss today. So this belongs to the chapter hydrocarbons. About hydrocarbons, I have already discussed with you what are hydrocarbon, what is their classification, what is the nomenclature of hydrocarbons, and what is the homologous series of hydrocarbon. All these things we have already discussed. Today we are going to discuss the another topic from the same chapter. The title for this topic is halogenation of alkane. Okay, title for the topic is halogenation of alkanes. Okay, now as we have discussed in the yesterday's session already about the alkanes are saturated hydrocarbons. Okay, yes, so today I am going to explain, as I have discussed with you already in the yesterday, that I will explain saturated hydrocarbons in tomorrow's session. So what is the meaning of this saturation that we are going to see now? So alkanes are saturated aliphatic hydrocarbons. Alkanes are saturated aliphatic hydrocarbons. Okay, yes, so let me just tell you again. So if you have any kind of doubts in between, you can any time ask me in the chat box. I'm just sending one message in the chat box. Whenever you have any question in mind, you can ask me in the chat box. Okay, so saturated aliphatic hydrocarbons are what we will discuss today. So about carbon, we have seen carbon is tetravalent in nature, right? Carbon is tetravalent atom. Okay, tetravalent atom means what? Tetra stands for 4, valent stands for valency, right? Valence stands for valency. Valency is nothing but the bonds attached to that particular atom, the ability of that atom to form these many number of bonds. That means carbon can form the 4 bonds surrounding to it. That means there should always be 4 lines surrounding to the carbon. Now how carbon can form 4 lines surrounding to it? First possibility, like this, carbon can form 4 lines surrounding to it. Second possibility, third possibility, fourth possibility, okay. So these are the possibilities of carbon to be tetravalent in nature. Can you see? In all these possibilities there are 4 lines surrounding to the carbon atom, right? 4 lines surrounding to the carbon atom, right? Okay, now in these possibilities, if you can see here, there are double and triple bonds, right? In these possibilities, these 3 green colored possibilities, if you can see, there are double and triple bond. So always remember, hydrogen always form only single bond. Okay, hydrogen only can form single bond, right? Hydrogen only can form single bond. So can hydrogen be present here? No. Can hydrogen be present here? No. Can hydrogen be present here? No. Hydrogen cannot form double or triple bond. Hydrogen can always form only single bond, right? Okay, therefore the tetravalency of these 3 possibilities, the green colored possibilities, is not completely satisfied by hydrogen. Okay, here it can be carbon or nitrogen or oxygen, likewise, right? Here it can be any other atom, but it cannot be hydrogen, right? That means their tetravalencies are not satisfied completely by hydrogen atom, right? Therefore we call them as unsaturated. Therefore we call them as unsaturated hydrocarbons, right? Therefore we call them as unsaturated hydrocarbons, right? Why? Because all of their 4 valencies are not satisfied by the hydrogen atom, right? All of their 4 valencies are not satisfied by the hydrogen atom, right? But if you can see here, for this structure, the valencies are or can be satisfied by hydrogen atom, that is surrounding to the carbon atom. The all of them can be hydrogen atom, or even if it is a carbon atom, that is also can be attached to it by the single bond, right? That can also be attached to it by a single bond. If all the single bonds are present surrounding to a carbon atom, all the single bond, then that will be called as a saturated hydrocarbon, right? That is called as the saturated hydrocarbon. In case of alkanes, we have already discussed about alkane. In case of alkanes, all the bonds are single bonds, right? In case of alkane, all the bonds are single bonds only, right? It contains only single bond. What type of single bonds? Carbon to carbon single or carbon to hydrogen, but only single bonds are present in case of alkane. Therefore, alkanes are known as saturated hydrocarbons, saturated aliphatic hydrocarbon. Alkene and alkynes are known as unsaturated aliphatic hydrocarbons, right? Okay, I hope you got this. So as far as alkanes are concerned, they are having carbon to carbon or carbon to hydrogen single bond. Therefore, the carbon to carbon and carbon to hydrogen bond are not that much easy to break. Do remember I have told you the covalent bond can be of two types. Covalent bond can be direct contact, that is if my two hands are the atomic orbitals. If they are directly touching each other like this, then direct contact is the sigma bond, where if they are not directly touching, if these are the atomic orbitals only, they are having a lateral or parallel overlap, that is the pi bond. Pi bond is present in double and triple bond, right? Okay, can you see? So pi bond is present like this. So if this is a single bond always contains only sigma bond. Single bond only contains always a sigma bond. A double bond is made up of one sigma, one pi bond, and a triple bond, that is 3 lines, is made up of one sigma and 2 pi bonds, right? As I have told you, pi bond is easily can be easily broken, but sigma bond takes more energy to break. Therefore, for alkanes, the reactions are very rare. Alkanes are less reactive as compared to alkenes and alkynes, right? Therefore, you can see very few reactions are there for alkanes, right? Alkanes show very few chemical reactions, out of which one such a reaction we are going to discuss in today's session, that is called as the halogenation reaction. Okay, before starting halogenation, actually you can just take a screenshot of this page, and then we will write down, or then I will write down the halogenation reaction. Take a screenshot of this page. Halogenation reaction. Now halogenation means what? First of all, let us see the meaning of this word halogenation. Okay, halogenation. So here we are incorporating the halogen atom in the structure, therefore this is called as halogenation reaction. So what is the meaning of halogen? Halogens are nothing but the group number 17 elements. We know that, we have learnt it in the periodic classification of elements. The group 17 element which belongs to the P block, group 17 elements. Group 17 element is on the right hand side of the periodic table. We know that On the right hand side of the periodic table there is P block. This is a P block, right? On the extreme right hand side of the periodic table. So in this right hand side, in this P block, there are 6 groups, right? So this is group number 13, this is 14, 15, 16, 17 and 18. 18th is the group of noble gases or inert gases, whereas 17 is the group of halogens, right? Okay, 17 is the group of halogens. Now that's why this is group 17 elements, that is halogens. Why the group 17 elements are called as halogen? There is a reason for that. I'll tell you. Before that, let me write down here. These are the elements belonging to the P block of modern periodic table. Why these are called as halogens? Halo stands for, okay, halo has come from the Greek word halos. Okay, the meaning of this word halo is sea salt. Okay, salts which are present in sea. Whereas gens, gens stands for producers. Okay, gens stands for producers. So group number 17 elements are sea salt producers. Okay, that is, for example, NaCl. NaCl is the salt present in sea, out of which Na belongs to group number 1 alkali metal. Cl, that is chlorine, belongs to the group number 17, right? Like NaCl, so many other salts are present in sea. Therefore, group 17 elements are called as halogens, sea salt producers, right? What are the different halogens? We know the group number 17 starts with fluorine, then chlorine, then bromine, then iodine. Then after iodine, astatine is also there, but that is radioactive in nature. At, astatine, that is radioactive in nature. That means it is highly unstable. As it is highly unstable, it will not undergo any reaction. So many a times it is not included in halogens for the chemical reactions. Okay, yes. Now this is the group number 17. Okay, this is the group number 17. Now we have learned some properties of group number 17, and that is about the, first of all, atomic size. Okay, as we know, atomic size down the group goes on increasing, right? Atomic size down the group goes on increasing because a new shell is introduced at every level, right? Fluorine is the smallest, iodine is the largest in atom in this case, right? Out of these 4. Next property we have discussed, next important property is about En. En stands for electronegativity. Electronegativity down the group goes on decreasing. Okay, electronegativity down the group goes on decreasing, right? Electronegativity down the group goes on decreasing. That means if I want to write down the electronegativity order, fluorine is most electronegative, then chlorine, then bromine, and then iodine, right? Electronegativity is the tendency to attract the bonding electron towards itself, right? Okay, yes. So fluorine likes the electron very much as compared to chlorine, bromine, and iodine. Okay, yes. So these are the properties of elements required to learn the halogenation reaction, right? Okay, now alkanes are the starting materials, right? Alkanes are the starting material. What happens here? The hydrogen of alkane is replaced or substituted by halogen atom. I will repeat. What happens in the halogenation reaction? Hydrogen of alkane is replaced by the halogen atom, right? The reactions can be carried out at by heating or in the presence of sunlight, or some another ways are there for carrying out this reaction, but using the sunlight is the most popular way for carrying out the chlorination. Chlorination means what? If I am using chlorine gas, okay, then specifically it is halogenation only, but specifically it will be called as chlorination. If I am using fluorine gas, F, then it is fluorination. If I am using bromine gas, then it is bromination. Okay, likewise. Okay, yes. So but chlorine is very popular in it. Okay, chlorination is very popular in it. What happens here? The hydrogen atom of alkane, let us take the simplest example of an alkane, that is the methane. The single carbon containing alkane is the methane. There are 4 hydrogens in it. if I treat it with the chlorine gas in the presence of H nu. Okay, what is H nu? I have told about H nu in some class. In short, I'll just write it down here. Okay, H nu means photon of light. Photon of light. Okay, here H is the Planck's constant. Okay, H is the Planck's constant, and nu, you know, it is the frequency of sunlight, frequency of that light, right? Yes, so H nu, whenever we carry out the reaction in the presence of sunlight, at that time we write down H nu on the reaction arrow. H nu stands for sunlight. Okay, yes, and chlorination is performed in the presence of sunlight, right? So what I have told you here, the hydrogen, one of the hydrogen is replaced by the halogen. Instead of writing chlorine gas as Cl2, I'll write it like this. Okay, in chlorine gas, two chlorine atoms are attached to each other, bonded to each other like this, right? So in this reaction, what I have told you, the one of the hydrogen is replaced by the halogen atom. What happens here? One hydrogen of alkane and chlorine of Cl2 is eliminated in the form of HCl, right? They are forming the HCl, which is a byproduct, whereas the another chlorine gets attached to the carbon atom. Okay, another chlorine gets attached to the carbon atom, right? So this particular compound which is obtained here, this is called as chloromethane. Okay, this is called as chloromethane. Okay, chloromethane, or this is also called as methyl chloride. Okay, chloromethane or methyl chloride. Now there are still 3 hydrogens present in chloromethane, so reaction won't stop here. Reaction will be again carried out further if it is further treated with another molecule of, I'll write it down below instead of here. So I'll take the chloromethane. Chloromethane further again reacts with another. Now chloromethane, I will write it like this. Okay, Cl I will write down below and H here, so that I can show the loss of HCl. Okay, if it is further treated with Cl2 and H nu, here also there will be loss of HCl, right? Okay, HCl will be the byproduct, and what will be the product here? So it is C, H, H, and there will be 2 Cl2 attached to it. Okay, yes, and then I forgot to write down its formula. Chloromethane or methyl chloride is CH3Cl. Okay, yes, then this compound which is obtained here, the name of this compound is the dichloromethane. Di stands for 2, right? So dichloromethane, okay, dichloromethane is also abbreviated as DCM. Okay, DCM, which is used as very popular organic solvent. Okay, what do you mean by organic solvent? You know, many of the time when we are performing chemical reactions, during some chemical reactions we should use organic solvent, because some organic compounds are not soluble in water, right? They don't like water, they are not dissolved in water. So to dissolve such a compounds, we are using the organic solvent which contain carbon and hydrogen or any other element like chlorine here. So DCM is very good solvent, very good organic solvent, dichloromethane, or it is also called as, there is one more name to this, methylene chloride. Okay, methylene, the meaning of word methylene is CH2. So if methylene is there, obviously there will be 2 chlorine atom, that is a clear picture. So no need to write down methylene dichloride, only methyl chloride is enough. Formula will be CH2Cl2, right? The reaction will not stop here also. The reaction, further reaction takes place, because there are still 2 hydrogen atoms. So now again I will write down the structure like this, so that I can show the loss of HCl molecule. So this is your DCM. It further reacts with another chlorine molecule, chlorine gas, in the presence of H nu, that is sunlight. right? Okay, here also the loss of HCl takes place, and one of the hydrogen is replaced by chlorine. Okay, so what we are getting here, there will be one hydrogen attached to carbon and three chlorine atoms, right? Okay, this compound is called as chloroform. Let me first write down its IUPAC name. This compound which is written here, it is called as trichloromethane. Tri stands for three chloro present in methane, so it is called as trichloromethane. Okay, or it is also called as, popularly it is called as chloroform. You might have heard this name chloroform. Previously chloroform was used in anesthesia. Okay, you might have seen the chloroform bottle in Hindi movies also, you know, to the usually it is used by the for the person. If someone is smelling that chloroform for the longer time, the person will faint, right? So if you are smelling the chloroform, I'll tell you one very interesting thing about it. When while doing research in IITs, I observed that when you are smelling it for very small time, like, and very small extent, if you are smelling, it's really very sweet smelling compound. Okay, it's really very sweet smelling compound. But if you smell for longer time, then obviously you will faint. So that is the beauty of organic compound. That is the beauty of chemistry. So always remember, in chemistry, if something is looking, some chemical is looking very beautiful in color, as far as color or as far as smell is concerned, if it is having very good smell, then you can consider it to be very harmful. Okay, n number of examples are there. One more example I'll give you, toluene. So toluene, so TOLUENE, this is also one of the compound which, if you smell, you will have the addiction of that toluene smell, right? There was one news just 10-15 years back, like, people, children, not people, specifically children, who were staying in the slum area. So were buying the whiteners, whitener we use when we want to correct anything on the notebook. So that whitener has a specific smell. If you have ever used it, you will observe that is having a specific smell. So if you smell it for a longer time, you will be habitual to that smell. So that's why these children were staying in that slum area in some region in Maharashtra. They were buying these whiteners, and then finally, obviously, when people came to know about it, then that was banned in that area. So this toluene is one other such an example of beautiful, or the chemical compound which is having a very interesting or pleasant smell. So likewise, chloroform is also the same. It is having very good smell if you are smelling it for long, very short duration, or if you are smelling it in very small extent. But if you are smelling it for longer time, prolonged exposure will cause the nausea and you will faint. So chloroform, previously that is the reason it was used in anesthesia. Nowadays we are not using chloroform for anesthesia. Some other chlorine and fluorine containing compounds are being used due to some disadvantages of chloroform in using in anesthesia. Okay, so chloroform chemical formula is CHCl3. Okay, again still there is one hydrogen present here, right? So that also will be substituted by the halogen, right? So let me write down the hydrogen on the right hand side and chlorine like this, so that I can show the loss of HCl. Again, if it is further treated with Cl2 in the presence of sunlight, there will be loss of HCl. HCl is a byproduct again, and we are getting now all the hydrogen atoms of methane are substituted by chlorine. Can you see? There is no any hydrogen atom present in the compound. So this is called as tetrachloromethane. Tetrachloromethane is the IUPAC name. Popularly, or in the common name system, it is called as carbon tetrachloride. Carbon tetrachloride. Okay, and the formula is CCl4, right? In CCl4 you can see there is not a single hydrogen present, not a single hydrogen left behind, therefore the further reaction will not take place. Okay, further reaction will not take place. So this is called as halogenation, or more specifically chlorination of methane. Just like methane, all other alkanes will undergo the halogenation reaction, chlorination specifically reaction in the presence of sunlight. For chlorination reaction, sunlight is necessary. For fluorination reaction, no any sunlight, no heat is required, because it's really very reactive in nature. For bromination, heating is necessary. For iodination, the reaction is little bit difficult. The prolonged heating in the presence of catalyst is required for iodination. Okay, therefore chlorination is really very popular in halogenation reaction of alkanes. So this is for methane. This is the simplest one. Just take a screenshot of this page first of all. Then I will tell you about some questions related to this chlorination or halogenation reaction which can be asked in the competitive exams. Okay, I hope you have taken a screenshot. Now let me just explain something related to this chlorination or halogenation reaction, and that is about the rate of reaction. Mechanism of this reaction we are going to discuss some another day, and because it will take at least 1 hour to discuss the mechanism of the chlorination or halogenation. Rate of reaction, rate means speed, okay, not a rate. So rate of reaction is the speed of reaction or velocity of reaction. So if they ask about the rate of reaction, okay, in which case the rate will be fastest. So for the halogens, the rate of reaction order for halogens is fluorine is the most reactive, then chlorine, then bromine, then iodine. Okay, this is the rate of reaction for the halogens. Okay, the halogens. Then if I am talking about alkanes, okay, rate of reactions for alkanes. Yes, one more thing about rate of reaction. Yes, so as fluorine is the most reactive in this case, therefore fluorination is very violent to be controlled. That is, reaction is very violent. We cannot control the reaction. Okay, tremendous amount of heat will be produced. Therefore, fluorination is not practically performed. Okay, and iodination is the slowest reaction, and therefore, as it is slowest, therefore reversible also, slowest and reversible reaction. As iodination is reversible, and hence to avoid that reversible reaction, we are going to use some oxidizing agent. Hence it is performed in the presence of oxidizing agents. If you are using oxidizing agents, the reaction will not go in the reverse direction, like HiO3 or HNO3. Remember this, okay? They ask this question, why oxidizing agents, why they are used in the iodination reaction. Okay, then this was about the halogens, right? Now, if they ask the order for alkanes, okay, order of order for alkanes, for different types of alkanes. Now in that case also the tertiary will be more reactive than secondary than primary. Okay, so tertiary carbon, the hydrogen present on tertiary carbon will be substituted very easily than secondary than primary. So what is the meaning of it? I'll tell you. So if I have the isobutane, okay, for example isobutane, okay, isobutane. So what is the structure of isobutane? CH3, CH, CH3, CH3. This is the structure of isobutane, right? Okay. So here what happens? There are different types of carbon atoms. I will expand the structure. So C attached to H, then C attached to isobutane, right? So this is C, H, H, then this is C, H, H, then this is C, H, H and H, right? Okay, now here you can see there are different types of carbon atom. So carbon atom which is attached to three other atoms is the tertiary. So this is a tertiary carbon, this is a tertiary carbon. Carbon atom which is attached to two other carbon atoms is the secondary, which is not present here. Carbon atom attached to three hydrogens, it is the primary. So these three are the primary carbon atoms, right? Okay, therefore here what happens, the reaction at this will be faster. That is, if I ask you out of this which hydrogen will be substituted fastest with the halogen, so this will be substituted fastest with the halogen, right? So this is about the rate of reaction. Okay, now take a screenshot of this part also. Okay, I hope it is done. Now that's all for today. In the next class we are going to discuss the another concept from the chapter, another concept from the same chapter, another chapter. So before that, before ending the class, let me just show you the DPP, daily practice problems. Okay, I hope you are able to see the DPP. So this is a teachers portal. Similar will be the teachers student portal also. You have to go to resources, then to writing material, in which you can see the DPP, daily practice problem. You can download the daily practice problem here. You can solve the questions, write down the solutions and answers on your notebook, take a picture of that solutions and upload the image on your portal, so that teacher will be able to see the solutions by you, and teacher will evaluate it and let you know the suggestions wherever required. I hope you understand that. So that's all for today, and tomorrow we are going to discuss another topic from chemistry. Thank you so much students for your precious time. All the best to you and take care.